Okay, hi everybody. This is lesson 3 for unit 2. By the end of this lesson, you'll be able to explain why statistics are important to psychology by participating in a mean, a median, and a mode activity. We're going to focus on statistical reasoning in everyday life. Describing data and how do we measure central tendency. First, we take a look at the mode, and this is the number that occurs the most often, the most frequently. Then we take a look at the mean, and this is the average, before we finally figure out the median, which is the middle score. So if I list all the scores in order from highest to lowest, the one that's in the middle is going to be my median score. Just kind of takes a look at it. If we have income per family, thousands of dollars, these are the individuals. We've got the mode, the number that occurs the most often, which is 40,000. We have the mean, the actual average, because we've got people that make a lot of money and then people that don't make a lot of money. The average is right here in the middle. And then we have the median or middle score over here. Measuring the variability range is going to be the difference between the highest and lower scores in a distribution. Standard deviation is a measure of how much scores vary around the mean score. I have a visual that will help make this a little bit more sense here in a minute. How you calculate the standard deviation, you will never have to do this, but this is just so you know how they calculate it. It's the sum of all the deviations that we put to the square divided by over the number of scores, taking the square root of that number. Now again, you're never going to have to do that in this class. If you move further along in psychology, you probably will have to. So here is standard deviation. If I have the intelligence scale, I know that on average, the average score is 100. Now, if you had a perfect standard deviation, which is what we see here, 34% of the people are going to score within one standard deviation of the test. So that means that 34% of the people are going to score between 100 and 115. And it looks the exact same on the other side if it's a perfect bell curve. That means that 34% of the people are going to score between 85 and 100%. Or 100, I'm sorry, not 100%. Between 85 and 100. So we have 68% of the people are going to score between an 85 and 115. And if you're giving a test, this is kind of what you want to see happen. Now, you can expand it out to another standard deviation. If you go out one more standard deviation, then that should include an additional 13.5% that will take you from the 115 to 130 mark and from the 85 to 70 mark. So total, 95% of the people should fall between two standard deviations of the mean. All right, making inferences when you're doing experimental studies. When can we make inferences? When is an observed difference of reliability? So when is it when we see something and we notice it's different, we can actually trust it? Well, the first is if it's a representative sample. If it's a representative sample, then that's better than any other sample. Second, it's a less variable observations are more reliable than those that are more variable, meaning the more that you can control and not have other things impact your observation, the more reliable they are. And the more cases you have, the better off you are. So you want to be studying more than one person. You don't just want to study one person. And when is the difference in our study significant? When can we actually say, oh, wow, this means something? Well, it has to be statistically significant. And that means how likely is it that an obtained result occurred by chance? So if it's not very likely that it occurred by chance, then it's not very statistically significant. Taking a look at averages. So if the average is reliable and the differences between averages is relatively large, this implies the importance of the results. And that is it for today.